What is solar energy? Solar energy is the energy from the sun that is converted into thermal or electrical energy. Solar energy is the cleanest and most abundant renewable energy source available. How solar energy is created? Solar energy is created by nuclear fusion that takes place in the sun. Fusion occurs when protons of hydrogen atoms violently collide in the sun core and fuse to create helium atoms through proton-proton chain reaction. The enormous amount of energy is emitted from the reaction. The energy produced, light and heat from the sun are transmitted to the earth in the form of electromagnetic radiation. History of solar energy. The use of solar energy by humans can be tracked back to the 7th century BC. The ancient civilizations used passive solar design for a range of different purposes. For example, Greek and Chinese designed whole cities with the sun, thermal mass, and ventilation in mind, positioning buildings so that they would remain cool during the summer and be heated by the sun rays during the winter. Romans used the sun's energy to heat their bathhouse through the process called hypocausts. While in ancient Egypt, they designed their homes and used solar mass to trap the sun's heat during the day, which was then released at night to keep their homes warm. Besides, they used solar energy to evaporate water for cooling purposes. The Romans and Greeks also used magnifying glasses and mirrors to light fires. In 1767, the Swiss physicist Horace Benedict de Saussure created the first solar collector cell which able to magnify the sun's heat by the glass inside to 108 degrees Celsius to boil water and cook food. In 1883, Charles Fritz invented the first solar cell to produce electricity from sunlight, and it is installed on the rooftop in New York. In 1905, Albert Einstein discovered light particles, known today as photons. In 1954, scientists at Bell Labs created the modern solar electric cell, which can generate strong electric current when exposed to light. At first, solar panels were only used to power remote pieces of electrical equipment such as rural telephone lines and satellites in space. In fact, the first satellite with solar cells, Vanguard 1, was launched in 1958. At the end of 20th century, engineering improvement had made solar cells cheaper and easier to make. More solar panels are installed on rooftop and appear in larger solar farms to generate electricity for regular use.
Basic mechanism on how the energy is produced from the source. There are two ways to convert the energy from the sun. The first way is photovoltaic PV conversion, while the second way is solar thermal conversion. In the PV conversion, a PV system is needed. The PV system consists of PV cells, PV panels, and PV arrays. Before we talk about the basic mechanism of a PV system, it starts by mentioning PV cells, also known as solar cells, which convert sunlight into electricity and can also convert artificial light. These cells are connected to form PV panels with the electricity generating capacity increasing with the number of cells or the panel surface area. A PV array is then described as a group of PV panels with the amount of electricity generated depending on the number of panels in the array. The array PV cell works. When sunlight hits a solar panel, it causes electrons in the solar cells to be knocked loose from their atoms, a process known as the photovoltaic PV effect. An array of solar panels then converts this solar energy into direct current DC electricity. The DC electricity enters an inverter which converts it into 120-volt alternating current AC electricity. This AC power enters the utility panels in the house, where it is distributed to appliances or lights. Any excess electricity generated can be stored in a battery as DC electricity. When the battery is full, the excess electricity can be exported back into the utility grid. Conversely, when not enough solar energy is produced, electricity can be drawn from the grid. The flow of electricity in and out of the utility grid is measured by a utility meter, which spins backwards when excess electricity is exported. This system known as net metering. The term solar thermal is used to describe a group of technologies that capture the heat energy from the sun and use it for various forms of heating and the production of electricity. For heating, solar thermal systems are referred to as passive or active. Passive systems are more basic and have no moving parts. They simply rely on design features to enhance our ability to capture and use the sun's rays, like a greenhouse or a solar oven. Active systems have mechanical components like fans or pumps to circulate heat carrying fluids. These systems can be used for residential or commercial heating. Let's take a look at the process step by step. An evacuated solar collector is fitted to the roof to absorb the sun's heat and transfer it to fluid in the solar circuit pipes. The solar circuit transports the hot fluid from the collectors to the hot water cylinder. The hot water cylinder receives the hot fluid and transfers the heat to the domestic hot water supply.
Okay, next I will present about the advantages of solar energy. First, solar energy is renewable energy source and reduce carbon emissions. We don't ever use it up, and solar energy is clean. It creates no carbon emission or other heat-trapping greenhouse gases. It avoids the environmental damage associated with mining or drilling for fossil fuels. Second, solar energy reduce electricity bills. Choose solar energy that are powered by the sun instead of home's electrical system to help save money. Last but not least, solar panels have low maintenance costs. Solar panels are easy to maintain as they have no moving part that wear out over time. Just keep them clean and in good physical condition to keep them working properly. Okay, we move on to the disadvantages of solar energy. First, solar energy is weather dependent. The efficiency of the solar system drops during cloudy and rainy days. Solar panels are dependent on sunlight to effectively gather solar energy. Solar energy cannot be collected during the night. Second, solar panel that we use to get solar energy use a lot of spaces. The more electricity we want, the more solar panel we will need. Solar PV panels require a lot of spaces, and some roofs are not big enough to fit the number of solar panels that we would like to have. Third and last, solar energy also have high initial costs. This is because a complete solar installation requires significant investment.
Now, we will look at the countries that using solar energy. Many countries around the world that are utilizing solar energy to varying degrees. Here is an overview of the top 5 nations that leading in deployment of solar energy based on statistics by the International Energy Agency (IEA). Coming in the first place, China is the largest producer of solar panels, while US ranks second globally in terms of cumulative photovoltaic 141.8 gigawatts installed capacity. Next, Japan ranked third globally with a total installed photovoltaic capacity of 84.9 gigawatts, while Germany, which is the largest economy in Europe, ranked fourth in terms of installed solar capacity with 69.1 gigawatts. Last but not least, India stands fifth in solar power with a cumulative PV installed capacity of 68 gigawatts. Goals to achieve regarding solar power. The need for sustainable energy solution has grown urgently as the globe struggles with climate change and its effect on the environment. With its renewable and sustainable qualities as well as its potential to assist nations in achieving their Sustainable Development Goals (SDG), solar energy has become a very attractive alternative. Consequently, nations are moving toward enhancing their use of solar energy. In China set a goal in its 14th five-year plan, which was unveiled in June 2022 to source 33% of its electricity from renewable sources by 2025. Moving on to the next goal, in US, the administration under President Joe Biden has announced a goal of reaching 100% clean energy by 2025. Out of this, solar power would meet 40% of the electricity demand. On the other hand, to meet the 108 gigawatts objective, Japan plans to install 20 gigawatts of solar power over the next 8 years, according to the Environment and Trade Ministries of the country. Furthermore, by 2045, the German government hopes to achieve net neutrality. The country has set an aim of installing 215 gigawatts of solar power by 2030 in order to achieve this goal. Lastly, by 2030, India aims to create 280 gigawatts of solar power capacity.
So, is it solar energy suitable to be used in Malaysia? Yes, is it? Here is why. First of all, because of its geographic location. Malaysia's position near the equator allows it to receive high level of heat and solar radiation, making it ideal for solar energy generation. The country's location enables it to receive solar radiation at a direct 90-degree angle, providing more energy per square meter compared to higher latitudes. Next, it is suitable for Malaysia because of its solar energy potential. Thanks to Malaysia's strategic geographical position, we are blessed with a natural tropical climate that allows us to have a daily average of 4 to 8 hours of sunshine and daily solar radiation as high as 4,500 kilowatts hour per square meter throughout the year. It is one of the highest rates in Southeast Asia. As a country that receives high solar irradiance, we have a good potential to harvest solar energy. The country's estimated potential for solar generation is up to 6,500 megawatts, making large-scale solar and rooftop solar a viable choice for solar deployment.